All right, 3.5.20. Solve that equation. You know, you could go into like a Desmos type of a program, and you could put in for your first equation, y equals n cubed minus n, and get the graph of that cubic. You could put in a second equation, y equals 5n squared minus 5, and look for where they intersect. And then just remember, the only solution are the x's, because in the original problem, there was only one variable. We're just using this y to help us find the answer, but you could do that way. We could also move everything to one side. So if I have n cubed, I'm going to subtract the 5n squared over to the left. So that's going to give me a minus 5n squared. And then I would have the minus n already sitting there on the left side. And then I'm going to add this 5n to the other side. And then since we've moved everything off from the right, the right side equals 0. So what we were looking, hello, this 5 doesn't have an n on it, does it? Always a good idea to check your work, especially if you're me trying to work problems. So n cubed minus 5n squared minus the n plus the 5. Okay. So then let's see. The rational root theorem says that we should use factors of this to see what the zeros are. So let's see. What do you think? 1 or a 5 or a -1 or a -5? I'm not really sure. Let's just try a 1. So I've got 1, -5, -1, +5. Let's see what happens. Bring down a 1, 1 and 1, add straight down -4. 1 times -4 is -4, add straight down -5. 1 times -5 is -5, add straight down is a 0. Lucky guess. So x minus 1 is one of the factors, because this 1, when does x minus 1 equal 0? When x is 1. That's, all right, then what do we have left here? We've got x squared minus 4x minus 5. Remember, the last number is the remainder. Number x's, x squareds as you come back. And then I think I can factor that to get the other two quickly. X minus 5 and x plus 1. -5 times 1, -5, -5x. +1x. Combine those together to get my -4x in the middle. When does the x minus 5 equal 0? At 5. And when does this x plus 1 equal 0? At -1. And so there are my 3 zeros. It said select the correct choice below the solution set. Again, use commas to separate them. So I would suggest the solution you should type in here for this problem would be the 1, the 5, and the -1, separated by commas. So problem 3.5.20, again, if you would prefer, like I've demonstrated in other videos, to take that equation, n cubed minus n, moving everything to one side, I'll put the minus 5n squared minus 5, and then jump over to, like I said, like a Desmos or using your graphing calculator. So there's my n cubed, had a minus 5n squared. I had a minus n, and I had a minus 5 for all of those. So I don't think I typed something right because I'm not in the right spot. I think I got a plus on one of those numbers. Let's go back and take a second look over there. I had the n cubed or plus 5 right here on the end. So the plus 5, and then hopefully we should see the -1, the +1, and the +5 for our solutions as well, using that method also. Again, like I said, the other method was if you took those two original equations, the n cubed minus n on the left, and the 5n squared minus the 5 that was on the right. And if you just type those into your graphing calculator or Desmos type of a program as your two equations, so that would be my n cubed minus n. And then in the other one, whoops, y equals 5n shift 6 for my caret squared minus 5. And so then when you did it this way, I do see my -1. I do see my +1, but where is, we had that other solution that was supposed to be at +5. So where is that? You might have to really come up here a long ways in this Desmos program before you ever got to that point to truly be able to see that it's someplace up here where it looks like it actually eventually did cross over. But just knowing both techniques, so someplace up in here there is also at that 5 a solution as well. A little harder to find it on this one by using that strategy though. So anyway, that's a couple different ways you can work that problem on that 3.5.20 problem.
Or stop by the main office. Nathan Anderson, please call 627 or stop by the